is for lesson 12.5, volume of prisms. What is volume? Volume is the space inside of a three-dimensional object. For example, how much water fits inside of a cup? Or how much can you fit inside of a box? Since we are measuring a three-dimensional measurement, our answer will be in units to the third power, or units cubed. Let's get started. First, let's look at rectangular prisms and cubes. You should be familiar with the rectangular prism formula, volume equals length times width times height. You've used that before. And for a cube, since the length, the width, and the height are all the same, then instead of saying length times width times height, we can say side times side times side, or side cubed. So let's give these ones a try. Here we have a cube because all the sides are the same. So we'll put our cube formula there, s to the third power, replace s with the length of the side, which is 3, and then calculate 3 to the third power, which is 27. That's 3 times 3 times 3, or 27 centimeters cubed. This one asks slightly a different question. It says, find the length if the volume is 96 centimeters cubed. So here we have the width and the height. We want to know what would the length be if the total volume is 96. So we take our formula and we're going to replace what we know. So we know the volume is 96, so we're going to replace V with 96. And then we're going to replace W and H with 4 and 6, leaving L as our missing variable. Now that kind of looks like a 1. If you want to change it to an X, that's totally fine. I'm going to multiply 4 times 6, which is 24, and now we have to figure out what number times 24, this is a missing value, equals 96. So 24 times what equals 96? I figure that out by dividing 96 by 24, which gives us L equals 4. Now, since this is just a length and not a volume, it is just 4 centimeters, not centimeters cubed. All right, we will now look at some triangular prisms. The triangular prism is a prism where the base is a triangle. So we see this triangle here. We're going to do 1/2 base times height. This gives us the area of the triangle, and then we multiply it times W, which is the space between the two bases. That's how much space we need to fill up. So we're going to multiply that area of the triangle, 1/2 base times height, times W. Let's give this first one a try. First, start by writing down the formula. Then we need to look at what is the base, the height, and the width of this triangular prism. Our base measurement is 5. Our height is 12, and our width is 10. So we're going to replace those in there, multiply the whole thing together, and our final answer would be 300 centimeters cubed. One way to think about a triangular prism is that it's half of a rectangular prism. So if I fill in the other half, you can see I can get a little rectangular prism there. And when we do volume of a rectangular prism, we just do length times width times height. But since the triangular prism is only half of that, that's where that 1/2 comes in. Take a minute to try this one on your own if you would like some practice. Here's our next example in our notes. Now we need to be a little bit careful with this one because if you notice the last one had the triangle facing us, kind of like this. This one that we're looking at is sitting on its triangle. So it's kind of been standing on its base, which is the triangle. So we're going to take our formula. The base of our triangle is this measurement here. That's 30 feet. The height of our triangle is 16. So we're just looking, when we're looking in here, we're looking at the triangle, not the whole prism, just the triangle. So that is 30 for the base, 16 for the height of the triangle, and then the width is supposed to be the width of the entire prism. If you remember from the first example, the width was this measurement right here between the triangle in the front and the triangle in the back. The width was how much space, like how far apart are the two triangles spread out. In this example, here's our triangle on the bottom. We have another triangle on the top, and the width is not going to be 30, it's going to be 15, because that's the amount of space between our two triangles. So what we have here is 1/2 times 30 times 16 times 15, which is a total of 3,600 feet cubed. The last formula that's on your formula sheet has a strange title. This says polygonal prism. And the picture that they're showing you is actually a pentagonal prism. So a little bit confusing because both of the words start with P's, of course, but remember a polygon is, the definition of a polygon is that it's any closed figure with at least 3 sides. So what that means is that this formula that we have down here would work for any type of prism. It actually would even work for a triangular prism, a rectangular prism, and a cube as well. But we're just going to use it for those odd shaped prisms, and we'll keep the other formulas the same. So the formula is V equals capital B times H, where capital B is the area of the base. So for example, in the pentagonal prism, the capital B would be the area of that pentagon on the bottom. Now we don't know how to find the area of a pentagon, so for these types of problems, you're going to be given that measurement on the bottom, that capital B, and then you'll simply need to multiply that times the height, which is the space between this pentagon on the bottom and the pentagon on the top. If you remember from our triangular prism, they were calling that W because the triangular prism was tipped over on its side. So we have V equals BH, where B is the area of the base. We are given that measurement. This is a hexagonal prism. 295 is the area of that hexagon times the height of the prism, which is 20, for a total of 5,900 centimeters cubed. Go ahead and take a minute to try this example and see how you do. If you have any questions, make sure you see me for help.